Yes, front end software, back end software. Yesterday we discussed. Sorry. Yes, languages, low level languages, high level languages. Yesterday we discussed about interpreter and compiler. These topics were discussed. Next, what is Java? Yes, about Java, we should discuss. Java, is it interpreter based or compiler based? Yes, we should discuss about Java. So what is Java? How Java is working? Let us see about Java. Yes. See here, Java. See, except Java, except Java, except Java, yes, other languages. Except Java, other languages. In other languages, what happens here? Except Java, in other languages. So first of all, source code. The source code converts into binary code. Source code converts into binary code. Yesterday we have discussed about the source code to binary codes, either a compiler or interpreter. Either a compiler or interpreter converts source code to binary codes. After converting to binary codes, just given to processor. So processor taking that code, generating output simply. This is except Java. Other cases, maybe C language or C++ or maybe HTML, something like this. One second, this girl has to rejoin. Yes, Anusha. Anusha has to rejoin. Has to rejoin the session. Has to rejoin. Yes, while joining here, yes, select audio. Select audio. While joining, select audio. Yes, Pauluri Anusha has to rejoin. Yes, this girl has to rejoin. She is in offline. Anusha has to rejoin. Pauluri Anusha has to rejoin. Okay. Yes. See here, except Java, other languages. Except Java, other languages. Source code converts into binary codes. That binary codes given to processor, then execute generating outputs. Okay. Yes. See, select audio. Select audio. While joining, select audio. Select audio. There's audio option. Select audio. Of course, by default, audio will be selecting automatically. By default, audio selecting, but try this one. Try this audio. Select audio again. Yes. Except Java, other languages. Except Java, other languages. Source code to binary codes. The binary code given to processor, then generating outputs. Source code to binary codes. Source code to binary code. This is either interpreter or compiler. Only one is enough. Only one thing here. Suppose Python interpreter converts source code to binary code. C language. Compiler converts source code to binary code. C++. Yes, compiler converts source code to binary code. HTML interpreter converts source code to binary codes. Either a compiler or interpreter. Either a compiler or interpreter converts source code to binary codes. Okay. Yes, Java. Let us say Java. About Java. Yes, if you Java, what happens here? In case of Java, what happens here? In case of Java, first source code, yes, first source code converts into byte codes. Source code converts into byte codes. Yes, in case of Java, source code converts into byte codes. That byte code converts into binary codes. Byte code converts into binary codes. That binary code given to processor, binary code given to processor here, generating output finally. So generating output finally here. Okay. Yes, source code converts into byte code converts to binary code given to processor here, then generating outputs. Yes, in Java, yes, there's the intermediate codes, byte code introduced. In Java, bytecode introduced. In Java, bytecode introduced here. So what's the purpose of bytecode? To make the Java as independent platform. So why bytecode introduced in Java? To make the independent platform, to make the Java as independent platform. Okay, purpose of bytecodes. Purpose of bytecode is to make the independent platform. Yes, we'll discuss now. Today we'll discuss about that independent platform features. Okay. So here in Java, in case of Java, what happens here? First source code converts into byte code to binary codes. So binary code given to processor generating output here. Okay. Yes. First source code to byte code. Source code to byte code. This part, this step is by the compiler. This step by the compiler here. So this is by the compiler. This is by the compiler. This is by the compiler. Next, byte code to binary codes. Byte code to binary codes. Byte code to binary codes. Byte code to binary code by the interpreter. This part is by the interpreter. This part is by the interpreter here. Interpreter. This part is by the interpreter. Interpreter. So there are two things involving in this: compiler and interpreter. Okay. See in Java, errors checking by the errors checking by the compiler, Okay, in Java errors checking by the compiler, Okay, so you can source code to bytecode. So compiler check for errors. Yes, errors checking by the compiler in Java. Errors checking by the compiler. Errors checking by the compiler. If no errors, then it generates bytecode file, bytecode file, bytecode file. It generates bytecode file. Okay, that means here source code. See here source code. Suppose test.java is a source code. This source code given to Java compiler, Java C, Java compiler, source code test.java, source code test.java, source code test.java given to Java compiler. So Java compiler taking test.java. After taking test.java, if no errors, if no errors, yes, if no errors, if no errors, yes, if no errors, yes, if no errors, then generating bytecode file. If no errors, so it is source code given to Java C compiler, source code given to Java C compiler. So Java C compiler taking the source code and converting it to bytecode file. Bytecode here, bytecode. Okay, source code test.java given to Java C compiler. If no errors, generating bytecode. Bytecode is a test dot class file generates. Dot class is a bytecode file. Dot java is a source. 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 So dot java is a source code here. Java dot java test.java given to Java C compiler. Java C compiler compiles generating bytecode file. So test.test file generates. So test Java C. Yes, here first source code test.java is a source code. Test.java is a source code. Test.java is a source code that converts into bytecode. Is a test dot class. So you get dot class for completely bytecode. It's a bytecode. So what is exactly bytecode? I'll explain. Yes, we'll discuss. What is exactly bytecode? We'll discuss. What is exactly bytecode? I'll explain very clearly here. Okay, I'll explain. We'll discuss that. Okay. Yes. Next here, tested dot class file. Yes, bytecode. Yes, but the bytecode file, tested dot class file, tested dot class file, tested dot class file. Yeah, this is given to Java interpreter. Java, it's an interpreter. This is interpreter. Interpreter. Yes, interpreter name is Java interpreter. Okay, Java interpreter name is Java interpreter. Yes, it's an interpreter. Okay, given interpreter. Interpreter. Yes, interpreter converts that Yes, interpreter converts dot class file line by line into binary code. Yesterday we discussed interpreter working line by line, right? Interpreter working is line by line. Interpreter working is line by line. So interpreter takes the Java bytecode file, yes, converts into binary code line by line and given to processor. So convert into binary code, converts into binary codes, converts into binary codes. Okay. So bytecode just dot class file contains what? Bytecode file. That bytecode file given to Java interpreter. Java interpreter. Java interpreter taking bytecodes, yes, converting into binary code line by line. First line converts into binary codes, then given to processor, just given to processor, given to processor. So processor generating outputs. After second line, after next line converts into binary code and given to processor. Next line, so line by line. See here, interpreter is line by line. Compile this whole program at a time. See here, Java C, Java compiler compiles whole program from top to bottom. Compiler compiles whole program from top to bottom. Yesterday, same point we discussed. Okay, yes. No, bytecode is different, machine code is different. Bytecode is different, machine code is different. I'll explain. Yes, source code converts into bytecode. So Java C compiler. So Java compiler converting source code to bytecode. Java compiler checking all the lines from top to bottom. checks It checks all the lines from top to bottom. Java compiler checks the whole program from top to bottom. Whole program from top to bottom. Top to bottom. Okay, if no errors, generating dot class file. So compiler. So here compiler involving errors checking by the compiler. Errors checking by the compiler. So this case compiler working here. So compiler working to check for errors. If no errors, generating dot class file. Now this dot class file given to Java interpreter. So Java interpreter taking that code here, line by line converting interpreter. When you're talking about interpreter, it's like the Java interpreter taking bytecode file and converting line by line. First line converting to binary codes and given to processor. Second line converts to binary code given to processor. Next line converts to binary code given to processor. So line by line converting into binary code and given to processor. So generating output here. Okay, let me show some example on this. Yes, suppose command prompt. Get the command prompt. Suppose D drive. Suppose test folder. Here suppose some test.java file is there. Yes, at the command line. D drive test folder. D drive test folder. D drive. Yes, D drive. Yes, D drive. D drive here. So dir output here. This is a test folder. Test directory. CD test. Change to test. CLS. Dir here. No test.java. Okay. Yes. No CMD. This is what? This is command prompt. It's a voice command prompt. It's not a compiler. CMD. It's a voice part. CMD is a command prompt. It's a voice part. It's not a compiler. Okay, CMD. Okay, CMD. Just it's a voice part. Okay. Yes. Here, Notepad C. Let us see some example. Notepad test.java. Notepad test.java. Open that. You can see here. Test.java. Suppose some Java program is like this. Okay, this is some comment here. Yes, public class test, public static void means string array faults. Hello world. Okay, yes, save and exit. Save and exit here. Okay, right? Yes, 1 second. Del start.class file. Yes, deleted CLS dir. See, no test.java file is there. Here they say test.java file. Here it's a test.java file. Okay. Yes, here it's a test.java file. Okay, test.java file. Here it's a test.java file. Test.java file. Here it's a test.java. Test.java. Now first Java C, Java compile, right? Java C, see this. Java C test.java. Java C test.java. See compiler. Yes, compiler checking for errors. Yes, no errors. Okay. Yes. So Java C test.java. Java C test.java. dir. See this test.class file generated. Yes, in test.java no errors. In test.java no errors. Test class file generated. So this is Java compiler. Java compile, right? So Java compile role is this. Okay, Java compile role is this here. So Java compiler. So compiling Java program, Java C test.java. After compilation, result file is test.class file. Test.class file generated. See this 10:25 AM just now generated. See September 2nd, September 2021. At this time, test.class file generated. Just now generated. So Java C compiler, Java compiler. Yes, compiling Java program. If no errors, generating dot class file. So dot class file generated. Now this dot class file is executing with Java interpreter. So Java interpreter test, right? Hello world, right? So compiler, this is interpreter. Okay, this is compiler, this is interpreter. There are two things involving, right? There are two things involving here. So Java C compilation part by the Java C Java compiler, program execution by the interpreter. See, this is compiler. Java C is a compiler. Java C means compiler. Java C means Java compiler. C means compiler. So Java C means Java compiler. So program errors checking by the compiler. If no errors, generating dot class file. The dot class file taking by the Java interpreter. Now it's here, it's interpreter. This is. So this is Java C Java compiler. Java means its interpreter. So there are two things involving here. Okay, program errors checking by the compiler, but runtime by the interpreter. Runtime by the interpreter. That's it. So here compiler as well as interpreter both are involving here. So compiler as well as interpreter both are involving. Okay. Now here in this series. So first source code to bytecode test dot class file Java C compiler. So test.java given to Java C compiler generating test.class file. Okay, so compiler is checking test.java top to bottom. If no errors, generating dot class file. Now this dot class file given to Java interpreter. It's an interpreter. Java, right? So test.class file taken by interpreter. Yes. So line by line converting into binary code given to processor, finally getting output. That's it. So this is what is happening inside of Java here. Okay. So involving both here, involving both compiler as well as interpreter. Okay, Java depends on, see Java depends on both. Java depends on, yes, Java depends on both the compiler, yes, compiler as well as interpreter, compiler as well as interpreter here, interpreter, compiler as well as interpreter, compiler as well as interpreter. Okay, compiler as well as interpreter. So Java depends on both compiler as well as interpreter. That's it. That's it. Okay. Yes. Next, one more point about Java here. Yes. One more point. Important point here. See errors checking. Errors checking by the compiler. Errors checking by the compiler. Right? Error checking by the compiler. Error checking by the compiler. But runtime. Yes, runtime by the interpreter. 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 Okay. Java runtime, program execution by the interpreter. So Java, yes, 1 second. Yes, some doubts. Mr. Javed Alam, your doubts. Yes, this is CMD. You're asking about this is CMD.
Yes, sir.
Yeah. Yeah, not this one. CMD.
At the top, at the top, you write Java C test.java, and that's a compiler part, right? And then it checks the error, and after that we do the interpreter part, Java test, and we write hello world.
Yeah, that is the case of Java. You asking about command prompt, right? CMD. What is CMD? CMD working like a what? Working like what? You ask this question, right?
Yes, sir.
You asking about this CMD command prompt. It's a interface given to you. It's a OS giving one interface to you. Okay. It's a command line interface. LI command line interface. Command line interface. Here you have to submit your request. It's the interface. Command line, command prompt that greater than, right? mnrock greater than, mnrock greater than, suppose D drive, D greater than, D drive greater than, suppose CT test, the test greater than. So what is the test greater than? It's a command line interface. It's the interface given to you. Yes, here you can submit a request. Suppose request is CLS means yes, OS will take CLS and execute CLS. Screen clear. Support the here. Okay, so this is command prompt. This is called as command prompt. This is this black screen. Here, this is a test greater than. It's a command prompt. At this command prompt, you can submit some commands like Java C test.java like this. Java C test.java. What happened? This is request for the OS. We are submitting request for the OS. Okay. Yes. So here this is a test. What is test here? D drive test. It's the interface given to you. It's the interface given to you. Here you can submit your request message. Is it clear? Okay, command prompt is a interface given to you. Yes, every request passing by the OS. Okay, every request passing by the OS, right? OS has to take your request. Where to submit your request? Command prompt. Command prompt. Okay, so this is the D drive test greater than this is called as command prompt. This is called as command prompt. CMD means command prompt. CMD means see this. CMD means command prompt. It's a command prompt. It's a command prompt. Okay. Command prompt is taking your request. Command prompt. Command prompt is to take your request. It's the interface given to you. It's interface given to you. Here you have to submit some request here. So now in case of Java, see this. So Java C and Java, right? So Java C is a compiler part. Java is an interpreter part. There are two things involving. There are two things involving in Java. There are two things involving in Java. So Java compiler and interpreter. Okay. Yes. Now here, see errors checking by the compiler, runtime by the interpreter. So program execution by the interpreter. Program execution by the interpreter. See, yesterday we have discussed one point. Yesterday, in yesterday discussion here, yes, last point. Yesterday, yes, we have discussed. See, interpreter based language don't have exe file. Okay. See, here, any language, runtime is an interpreter based. Interpreter based. Okay. Any language runtime is an interpreter based. Try to understand this point. Here some question for you guys. Here I'll be asking one question. Some question for you guys. See, any language is an interpreter based. Yes. Don't have exe file. Don't have exe file concept here. Don't have exe file concept. Don't have exe file concept. Don't have exe file concept. Any language runtime is an interpreter based. Don't have exe file concept. Okay. Now, see when come to Java. Yes, let us come to Java. Yes, Java language. Java language runtime is an interpreter based. Java language runtime is interpreter based. Okay. See, any language runtime is an interpreter based. Don't have exe file concept. Okay, any language runtime is interpreter based. No exe file concept here. Yes, when come to Java, Java language runtime is an interpreter based. Now question is, yes, is there any exe file concept in Java? The question. So what's happened here? See here. So what's happened in Java here? So first CLS, Java C compiled, generated one dot class file, yes, executing, right? Dot class file executed. Dot class file is not exe file. Dot class file is different. Exe file is different. Okay. So dot class file is a byte code file, it's not a binary code file. Dot class is a byte code file, not a binary code file. Dot class is a byte code file, not a binary code file. But dot class file is not exe file. Okay. Now question is here. What's the question here? Yes. Is there any exe file concept in Java? Or else question may be asking another way also here. Can we create exe file in Java? These are that anyone asking question. Yes, answer is yes or no. Tell me guys. So as per this, what you observed here, see what is observed here. So what is observed? So first, what is observed here? So using compiler test.java compiled, so got the test.class file. Using interpreter directly executed, right? Yes. Did you see anywhere exe file in this? Yes, in these steps here, have you observed any exe file in these steps? Yes. See this. Any language runtime is interpreter based don't have exe file. Java language runtime is interpreter based. Yes, if it is interpreter based, does it generate exe file? Yes, will it generate an exe file? Yes, now question is there any exe file in Java? Can we create exe file in Java? Yes, say yes or no answer. This is most important point. Compulsory interview question this is. Can we create exe file in Java? Yes, guys, please try to answer. Okay, yes. See, my classes are generally interactive classes. My classes are interactive classes. See here, see first test.java, test.java compiled, generated one dot class file, generated one dot class file. Dot class file is not exe file. Dot class file directly executed. Yes. Have you observed any dot exe file in this process? First compiled, first compiled. Dot class file generated, dot class file directly executed. Yes. Have you observed anywhere exe file is? Yes, come on guys. Yes, have you observed in this process? Yes, test.java got it. Test.class file got it. Where is test.exe file? No exe file. No exe file generated here. So simply dot class file directly executed. Yes, test.java converted dot class file, the dot class file executed. No exe file generated. So can we create exe file in Java? No, answer is no. We can't create. No exe file concept in Java here. Yeah, this is most important point here. No, answer is no here. No exe file concept in Java here. So there is no exe file concept in Java. Everything is dot class file. Okay, no exe file concept in Java here. Yes, no. Answer is no here. Yes, no exe file concept. No exe file. Yes, concept in Java here. In Java, no exe file concept in Java. Yes, Java here. Yes, here everything. Yes, everything is a dot class file. Here dot class file. Yes, always executing dot class files. All are dot class files. But dot class file is not exe file. See dot class file. Dot class file is not exe file. Dot class file is not a exe file. Exe file. Yes, dot class file is not exe file. Exe file is different, but dot class is different. Exe file contains binary codes. Dot class file contains byte codes. So this is different, that is different. Yes, we'll discuss. What's the difference between exe file, dot class file? That also we'll discuss now. Okay, so this is about Java. So Java depending on both the compiler as well as interpreter. Java depending on both. Java depending on both the compiler as well as interpreter. Errors checking by the compiler, runtime by the interpreter. Errors checking by the compiler, runtime by the interpreter. So both involving compiler as well as interpreter, compiler as well as interpreter. So in Java, depending on both the compiler as well as interpreter. That's it. Okay. Yes, maybe asking this question. Java. Yes, is it interpreter based or compiler based? Java compiler based or interpreter based? Asking this question depends on both. Answer is both here. Java depending on both here. Suppose scripting language depends on interpreter. Okay. Yes. See, this scripting language depends on interpreter. These are programming language depends on compiler. Java is a programming language. Java is a programming language. Even programming language depends on two things here. Depends on two things. Compiler as well as interpreter both here. Compiler as well as interpreter. So Java depending on both the compiler as well as interpreter here. That's it here. Okay, you have to answer that here. Okay. See, same point mentioned document. See the document here. Java depends on both the compiler as well as interpreter. See, Java depends on both the compiler as well as interpreter. Okay. See in Java, errors. Java errors. Errors checking by the compiler. Java errors checking by the compiler. Okay. If no errors, then Java compiler generates dot class file. If no errors, then Java compiler generates dot class file. Dot class file is a bytecode file. Okay. Java runtime by the interpreter. Okay. Error checking by the compiler. Runtime by the interpreter. See this. Here. See this. Yes. Source code dot Java given to Java compiler generating dot plus bytecode file. Yes, that bytecode given to Java interpreter. So generating bytecodes. So that bytecode is converting into binary codes. Okay, bytecode converting into binary code to OS libraries. This topic also will discuss now. Okay, then generating output finally here. Okay, so this is there are the steps. Okay, two steps: source code to bytecode to binary code. There are two steps, so two stages: source code to bytecode to binary code. Two stages. So first one, source code to bytecode. So bytecode to binary code, right? Okay. So in Java, bytecode introduced. So why bytecode introduced here? To make the Java as independent platform. Bytecode purpose is to make the Java as independent platform. Okay, see this here. Source code to bytecode by the compiler. Source code to bytecode by the compiler. Bytecode to byte to binary code by the interpreter. That's it here. Okay. Yes, Java depends on see Java depends on both the compiler as well as interpreter. See, Java runtime is an interpreter based. Java runtime is an interpreter based. Any language runtime is an interpreter based, no exe file. Any language runtime is an interpreter based, no exe file. Since Java runtime is an interpreter based, since Java runtime is an interpreter based, no exe file concept in Java. No exe file concept in Java. Now question is here, can we create exe file in Java? No. There is no concept of exe files in Java. Can we create exe file in Java? No. Answer is no here. No exe file concept. Okay. Yes. There is no exe file concept in Java. Yes, in Java, everything is dot class file. Everything is a dot class file. Dot class file is not exe file. Dot class file is not an exe file. Okay, it's not exe file. Dot class file is different, exe file is different. Yes, difference between dot class dot exe file we'll discuss now. Okay, yes. So this is about interpreters and compilers. Java depending on both compile and interpret, all that basics. Now we can understand features of Java. Okay, yes, now we can understand. Let us start. First one, independent platform. How Java made us independent platform. Okay, it's independent platform. Okay, yes, let us see about independent platform. Okay, so what does it mean? Yes, independent platform. So what does it mean here? It's independent platform. Question is, yes, what does it mean? What does it mean? What does it mean here? Independent platform. What does it mean here? Okay, Java is independent platform. Java is independent platform. What does it mean? Question is, what does it mean here? What does it mean? Independent platform. What does it mean here? Platform means what? OS. Yesterday we discussed it. OS is a platform. Operating system is a platform. Operating system is a platform. So OS means operating system. Operating system is a platform. On top of it, every program is running. So OS is acting like a platform. OS is acting like a platform. So your platform is OS. Independent of platform means yes, independent of OS. Okay, independent of OS. Okay, Java. So what does it mean? Yes, Java program. Yes, Java program. Yes, Java program running on anyways. So independent of platform means independent of platform. Yes, 1 second. Yes, independent of platform means Java program running on anyways. How next immediately question, how Java yes made us, how Java made us independent of platform, independent of platform, independent of platform. Okay, how Java made us independent of independent of platform. Okay, how Java made us independent of platform. Next immediately question, how Java made us independent of platform. Let us see. Okay, yes, 1 second. Yes, Ashish. Yes, compile once and run on any platform. JVM. Okay, fine. Yes. Yes, how Java made us independent. Let us see this. Yes. For this purpose, first of all, we should discuss about exe file. We should discuss about exe file. If you have that knowledge, then easy to understand independent of that from topic. Okay. Yes, exe file. Here, some question for you guys. Some question. Question is exe file prepared. Exe file prepared on Windows OS. On Windows OS. On Windows OS. Exe file prepared on Windows OS. Exe file question is exe file prepared in Windows OS. Yes, can I run on Linux OS? This is a question. Yes, anyone can you answer this? Yes, exe file prepared on Windows OS, can I run on Linux OS? Say yes or no. Exe file prepared on exe file. Exe file prepared on Windows OS, can I run on Linux OS? Say yes or no. Say yes or no. Yes, exe file prepared on Windows OS, can I run on Linux OS? Yes. Right? Answer is no. Answer is no. What's the reason? Yes. Yes. Can you tell me a reason? What's the reason? Yes. What's the reason? Yes. exe file prepared Windows OS, can I run on Linux OS? What's the reason? No. Answer is no. Answer is no. Reason. What's the reason here? Reason. Reason is exe file. Exe file is a OS dependent or platform dependent. exe file. exe file is a exe file is a OS dependent or platform dependent. Platform. Yes, platform dependent. Platform dependent. OS dependent. OS dependent. So that's the reason here. So exe file prepared on Windows OS, can I run on Linux OS? Answer is no. Answer is no. No. Reason. exe file is a OS dependent. OS dependent. Immediately question. Now immediately questions. Next question. So why exe file is OS dependent? Why exe file is OS dependent? Why exe file is OS dependent? Immediately question here. Yes. What's answer for? Okay. So why exe file is OS dependent? Yes. Anyone? Why exe file is OS dependent? Yes, I'll show you practically. Why exe file is OS dependent? I'll show you practically. Okay. Machine code is different. No, that is not the reason. Okay, machine code. See, 8086 processor. For Windows OS, 8086 processor. For Linux OS, also 8086 processor. Processor code is same. That code will not change. That binary code is same. Binary code no change. Binary code is same. Okay. Now current generation of computer, fourth generation processor based computers. Processor based computers. Okay, binary code same. No change. Then why exe file is OS dependent? Why exe file is OS dependent? So why exe file is OS dependent? Let us see. What's the reason for this? What's the reason? Let me show practically. Okay. Yes. Let me show practically. So why exe file is OS dependent? Yes. Linux base. So why exe file is OS dependent? Yes. Yes. No serious. See yesterday. Same discussed. Compiler part we discussed. Yes, cd mn raw directory. Yes, doesn't work in directory mn raw. Okay. ls see gedit test.c file. Gedit test.c file. See, this is C program file. This is C program file. Yesterday we discussed, right? Now what happens here? First, this program should be compiled. 1 second. Gedit test.c. Here, this is C program. White main, top to bottom, C program. Next, in this C program, one library added. Yes, it's a C software library, application software. C is application software. It's a C library. It comes on a header file, comes on library here. Header file comes on library. It's a library, C library. C library added to this, right? stdio data header file. This also has its own code. This stdio data header file has its own codes. All the functions defined in stdio data header file. This header file also having some codes here, some binary codes. This header file is already prepared file. This is already compiled and generated as binary code file. stdio data, it's a binary code file, already prepared file. Binary code file. It's a binary code file. Okay. Yes. Now next main program. This is your C program. Now here GCC hyphen C test.c. Yes, compiled ls test.o. What is test.o? This test.o file contains binary code of your C program. Just a binary code for C program. That main function, right? Yes, binary code for C program. This is your C program. So white main top to bottom, top to main function, top to bottom, right? Yes, this code converted into binary code. This code converted into binary code and generate as test.o file. So test.o file contains your C program binary code. That C program binary code. Okay, after that, next GCC hyphen o. Yes, no project. exe name is result. Exe name is project exe. Project exe test.o. Test.o, right? Yes, no project exe file generated. At the time of exe file generating, what happens here? GCC C language compiler. C language compiler taking your tested.o file means binary code of C program. Binary code of C program. A tested.o file contains .o means object file. It contains binary code for C program. It contains binary code for C program. Tested.o file contains binary code for C program. Next, stdio header file is also already prepared binary code file. That is also having binary codes. Okay, so here at the time of creation of exe file, that project exe file created, right? Project exe file, run it. Yes, yes. So got the output, right? Now at the time of creation of this exe file, at the time of creation of exe file, that C language compiler, it takes tested.o file means binary code of C program plus it will take stdio data header file binary code of library, C software library, binary code of library plus binary code for OS library. Yesterday we discussed every OS having its own library. Every OS has its own library to communicate between application software and hardware components, right? Yes, application software. Okay. Yes, every OS yes has its own library. Yes, let us see this. Every OS has its own library. See yesterday OS in this OS there is a library, right? Library. See here. Every OS has its own library. Its own library. Okay, input output library, OS library. So what happens here? Now here what happens? What happens here? Now that C language compiler taking binary code for your C program plus binary code for stdio.set file plus binary code for OS library, linking all these things, linking C program binary code plus linking that header file binary code and linking OS library. By linking all of things, generating exe file. So this project exe file is linked with OS library. This is called static linking. At the time of creation of exe file itself, linked means already linked. At compile time itself linking. If it is compile time itself linking, that is called a static linking. Okay, so static linking happening here. Static linking happening here, right? Yes, yes. Project exe file. Yes, exe file created. Okay, this exe file created and executed, right? Okay, now this is exe file. So you can exe file. So exe file. So why exe file is US dependent? Okay, region. Now here, see this. Yes, if exe file, yes, if C program exe file. Okay, if C program, if C program if C program exe file prepared, if C program exe file prepared on Windows space or Linux space, okay, Linux space, then it contains first one, yes, binary code for C program, yes, binary code for C program, binary code for C program, plus C program plus binary codes for, yes, C library means stdio data set file C library, C the binary code for C library. Okay, plus yes, binary codes for OS library, binary code for, yes, Windows OS library. Here it's a Windows OS library here. Windows OS library. Yes, Linux. Yes, sorry, Linux. Yes, Linux OS. Binary code for Linux OS library. This is finally exe file here. Okay. So any exe file contains OS library. Not only our code, OS library also. So binary code for C program. Yes, binary code for C library plus binary code for Linux OS library. Suppose if a C program exe file prepared in Windows OS, then it connects binary code for C program, binary code for C library, binary code for Windows OS library. So Windows OS library, Windows OS library, binary code for Windows OS library. Similarly, here one more example here, one more example, one more example. Suppose C++. If C++ program exe file, C++ program exe file prepared on Windows OS, then it contains binary code for C++ program. Okay. Yes. Next, binary code for C++ library plus binary code for Windows OS library. That's it. That is exe file. Okay. These are important, very, very important. Yes, no one will explain this. To explain these concepts is compulsory embedded C knowledge. Without embedded C knowledge, no one can explain here this kind of things here. Okay. Yes, my career started with embedded C. Yes, for initially first 4 years I worked on embedded C. Later changed to Java. Okay, so because of embedded C experience, I'm able to do this. Okay, now see this. Yes, now here. Yes, let us take some exe file. Suppose, for example, let us take some exe file. Example, example, example. Suppose test.exe file, test.exe file, test.exe file, test.exe file. Okay, for example, test.exe file. For example, test.exe file prepared, prepared. Test.exe file prepared on Windows OS, Windows OS, Windows OS, Windows OS. Then it contains Windows OS library, WinOS library. That's it. Okay, Windows OS library. Okay, now let us take different platforms. Test.exe file running on different platforms. Test.exe file prepared in Windows OS, then it contains Windows library. Means it is linked with Windows library. Test.exe file linked with Windows library. At the time of creation of exe file itself, at the time of creating exe file itself, that OS library linking to that exe file. So test.exe file prepared in Windows OS, then it contains Windows OS library. So test.exe file is already linked with Windows library. Okay, already linked. Okay, so test.exe file, test.exe file, test.exe file linked with WinOS library, WinOS library. Leverage. Okay. Now let us take different platforms here. Let us take different platforms. Okay, different platforms. Different platforms. Yes. Yes, hardware. Hardware. This is a hardware. Yes. 1 second. Hardware. Yes, hardware. 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 Yes, on top of hardware, this is a Windows OS. Windows OS, right? Windows OS. So Windows OS connects what? Win library. That Windows library here. OS connects library here. Every OS has its own library. Every OS has its own library. Okay. Now here, yes. Not test.exe file placing on Windows OS. See, hardware on top of it is a OS. So platform is now Windows platform here. On top of it, now placing test.exe file. Test.exe file. The test.exe file. Test.exe file. Okay. So this test.exe file. So test.exe file linked, right? That is all linked with OS library. So this test.exe file moving on to Windows OS. Place on Windows OS. Test.exe file. Test.exe file. Yes. When you place on Windows OS here, when you try to execute this, for test.exe file, yes, it makes a call to just a call to Windows library. Just a call to Windows library. Test.exe file. It will try to call Windows library. Test.exe file. When executing test.exe file, it will try to call to Windows library. Not test.exe file. It will try to call to Windows library. Yes, it's available. That Windows library is available. So simply Windows library is available. Just calling to Windows library. Okay, just a call to Windows library. So using Windows library, it will communicate with the hardware output device. That's it. Output or input device here. Okay. See test.exe file is called to Windows. Yes, test.exe file already linked with Windows library. Already linked means already prepared for Windows OS. Test.exe file already prepared for Windows OS. Already linked with Windows library. Okay. Now at runtime, it will try to call Windows library. Yes, it's available. It's available. It's available here. Try to call Windows library. It's available here. Using that library, it will communicate with hardware components. Okay. Input output devices. Yes, working fine. Now let us take another platform. 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 Okay. Let us take another platform. Okay. Yes. Now let us take Linux base. Linux base. Linux base can is what? Linux library. Linux base can is Linux library. Okay. Same test.exe file. Okay. Same test.exe file. Same test.exe file. See, same test.exe file place on Linux base. After placing a Linux base, try to execute test.exe. So when you try to execute test.exe file, yes, it called to Windows, yes, Windows library. Because test.exe file already linked with Windows library. The test.exe file already linked with Windows library. Okay, it will try to call to Windows library, but here is not available. OS changed. OS library, this library, that library is not matching. Test.exe file, it will try to call to Windows library, but it's not available. That library is different here, simply fails. Test.exe file fails. Okay, so test.exe file is OS dependent. Okay, the test.exe file is linked with Windows library. So when you try to run it another ways, it won't work. But because that library is not available. So really on Linux OS also Windows library is available, then test.exe file executes. On Linux OS also, Windows library is available. Windows library is available here, then test.exe file executes. But not available. So this OS is different, that OS is different, simply it fails. Okay, yes. Let us take another platform, suppose another platform, Unix platform, Unix base. Let us take Unix base with Unix library, Unix library. Not test dot here are same test.exe file. It will try to call Windows library, but here it's not available. Here it's Unix library. So simply not match, simply fails. That's it. Fails, simply fails. Simply fails, it won't work here. So test.exe file is OS dependent. What's the reason here? It contains OS library. That is a point answer here. Okay, here. So where is that question? Yes, why exe file is OS dependent? Answer is yes. It contains. Yes, it contains OS library. It contains OS library. That's it. Okay. So that exe file contains OS library. Since contains OS library is OS dependent. Yes, all these are interview questions. You have to face it. You have to understand. You have to face it. Okay. I'm sure no one will explain this kind of explanation here. I'm sure because here to explain this kind of things. Yes, that guy. Yes, the trainer must have embedded C knowledge also. Not only embedded C knowledge, real time experience. Without real time experience, without that embedded C means OS knowledge, including OS knowledge, how OS is working, OS behavior. Okay. Yes, the trainer must have the OS knowledge, OS behavior knowledge, next compiler knowledge, interpreter knowledge, next exe file knowledge, and all this. Otherwise, they can't explain here. Okay. So here because of my embedded C experience. Okay. So I'm able to explain this. Is okay. So this is the reason here. So why exe file is OS dependent here? Why exe file is OS dependent? Why exe file is OS dependent? Reason it contains OS library. It contains OS library. This is about exe file. This is about exe file. Fine. Now let us come to Java. Okay. Yes. I think it's clear, right? About exe file is clear. What is exe file? Exe file contains program binary code, software library binary code, and OS library binary code here. Since exe file contains OS library, it's a OS dependent. Simple conclusion. Simple conclusion. Exe file. Since exe file contains okay OS library, it's a OS dependent. I think this is about exe file. Is it clear? I think it's clear about exe file. Now let us come to Java. Let us come to Java. Let us come to Java. Let us come to Java here. Yes, in case of Java. Yes, same example. Let us take here. C program exe file. Okay. Same this example. C program exe file. Prepared and Windows. This is this same example for Java. In place of C, Java. Java program not exe file dot class file. Java program dot class file. Java program dot class file. Java program dot class file prepared on Windows OS. Then it contains what? It contains what? Not binary code, byte code. Byte code for Java program. 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 Byte code for Java program plus byte code. Byte codes. Byte code for Java library. Byte code for Java library. Next, binary code for OS library. No, don't have this much. That's it. This is dot class file. Dot class file contains byte code for Java program and byte code for yes Java library. Java library also developed in Java. Okay. So dot class file contains byte code for Java program, byte code for Java library. Java library also Java. So you get dot class file. Yes, dot class file. Dot class file is a pure Java program. Yes, pure Java program. Pure Java program. Okay. Yes. Yes, it does not contain. See, it does not contain. It does not contain any OS library. Any OS library. It does not contain any OS library. Yes, dot class file don't have any OS library. Dot class file it does not contain any OS library here. Any OS library. Dot class file don't have OS library here. So dot class file. So dot class file don't have. Yes, don't have OS library here. Don't have OS library. Okay. Don't have. Yes, don't have library here. Okay. Yes. Yes. Here dot class file. See this. Dot class file. See dot class file. Dot class file. Dot class file prepared. Okay. Dot class file. See dot class file prepared. Dot class file prepared on anyways. On anyways. On anyways. Dot class file prepared on anyways. Dot class file prepared anyways here. Dot class file prepared on anyways here. It contains only Java codes. Only Java codes. Only Java codes. Yes, don't have OS library. 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 So dot class file don't have OS library here. See any program file which is having OS library is OS dependent. Okay, exe file, C program exe file or C++ exe file, .NET exe files. That exe files contains OS library. Since exe file contains OS library, OS dependent, right? Okay, now you get dot class file don't have OS library. Don't have OS library, right? Okay, now let us take some tested dot class file. Tested dot class file. Let us take tested dot class file. Okay, tested dot class file on different platforms. Let us take first Windows platform. Let us take Windows platform. So Windows platform. Tested dot class file running on Windows platform. Yes, how it's working here. Tested dot class file placing on Windows platform. Okay. No tested dot class. So tested dot class program. It can be purely Java program. Okay. No tested dot class file. Yes, tested dot class. It's a tested dot class, right? So tested dot class file, tested dot class file simply placing on Windows OS. After placing on Windows OS here, not to run the tested.class file, this has to link with OS library, but not linked. Tested.class is a purely Java program, just a plain Java program. Don't have any OS library, but to run it, it should be linked with OS library. Yes, every program has to link with OS library. See, same point here discussed here. Every program, see this. Previously we discussed every program links with OS library, links with OS library before we start execution. Suppose exe file, at the time of creation of exe file itself linked with OS library. Exe file is already prepared file, already linked. It's a static linking. Exe file is already prepared, statically linked. At the time of creation of exe file itself linked. It's a statically linked. But when come to Java here, dot class file not linked, but it has to link. Okay, the dot class file don't have any OS library. Then how it can communicate with hardware? The dot class file has to link with OS library to communicate with hardware components. Yes, who will link it? Dot class file simply purely Java program. Dot class file is a purely Java program. Don't have any OS library, but it has to link. Before going to run it here, it has to link. Okay, so linking. Yes, dot class file linking with OS library. To link with OS library, one more layer comes here. One more layer comes. So between dot class file and Windows OS, one more layer comes. What is that layer? Can you guess it? What is that layer? Anyone can you guess it? What's layer? Okay, so between dot class file and this library, there's one more layer come to picture. That layer is a JVM. Now JVM come to picture. JVM come to picture. That layer is a JVM. Okay, now JVM taking dot class file, simply JVM. JVM taking dot class file links with Windows library. If OS is Windows OS, then JVM links with Windows library. So what is happening here at runtime? Dot class file, dot class file. Dot class is for byte code, right? Byte codes. Yes, that interpreter taking byte codes. So converting into binary code links with OS library here. So here there is a JVM. As a part of JVM, there is a interpreter. Inside of JVM, there is an interpreter. Inside the JVM, there is an interpreter. That interpreter taking dot class file, converting into binary format. That binary code links to OS library. Yes, as a part of JVM, there is a interpreter. This is the interpreter. Okay, interpreter. As a part of JVM, there is a interpreter. That interpreter. That in JVM, there is interpreter. Interpreter taking your dot class file, taking this dot class file given to interpreter. So interpreter converts dot class file to binary code. That binary code links to OS library. So once linking with OS library, then it communicates with the hardware component. That's it here. So JVM here, JVM takes care of linking. JVM takes care of linking dot class file to Windows OS library. If it is Windows OS, links to Windows library here. Once linked with Windows library, then executes and QB outputs. So its link is happening at runtime, right? That link is happening at runtime. So it's a dynamical linking. So it is a dynamically linking. It is a dynamical linking. C language exe file. If it is exe file, that is static linking, right? Statically means at the time of creation of exe file itself. At the time of creation of exe file itself linked. But dot class file what happened at runtime? Before going to run it, linking with OS library, then execution. It's a dynamical linking. It's a dynamical linking. Okay. Now let us take another platform. Let us take another platform. Another platform. Another platform. Okay. Another platform. Suppose tested.class file. Now tested.class file. Tested.class file. Placing another platform. Yes, Linux. Linux base. Linux base. Linux library. Linux library. Linux library. Now this platform, what happens here? Same process. Same process. JVM taking tested.class file. Okay, the dot class links to Linux library. It's happened at runtime. It happens at runtime here. At runtime, JVM taking test dot class file or links with Linux library. Once linked with this, communicates with the hardware commands. So JVM takes care of linking here. Depends on OS that link changes. If OS is dot class file, see dot class file don't have any OS library, but it has to link with OS library. Dot class file don't have any OS library. To run the dot class file, compulsory it has to link with OS library. Who will link it here? JVM. Depends on OS. If OS, current OS is Windows OS here, JVM links tested dot class to yes Windows OS library. Next, if OS is Linux OS here, then JVM linking tested dot class to Linux library. So this link is happening at runtime. That's the reason it's a independent of OS here. That link is happening at runtime here. It's happening at runtime. Let us take one more platform here. One more platform. Suppose Unix platform. Unix base. If it is Unix base, Unix base. Okay, if it is Unix base, Unix platform, Unix base, Unix library, Unix library, Unix library. Okay, that JVM, that interpreter, tested dot plus file. See tested dot plus file given to interpreter here. Interpreter links with Unix library here. Okay, then yes, communicates hardware. So here also JVM. So the JVM links with Unix library. So just JVM taking test dot class file, taking test class file, just links with Unix library, just linking with Unix library, just linking with Unix library. Okay. So JVM takes care of linking. It's a dynamically linking, depends on OS. Depends on OS, depends on OS that linking takes place. Depends on OS. Okay. So here JVM is responsible to make the Java is independent platform. JVM. So JVM here depends on OS here that linking link changes, dynamical linking changes here. Dot class file is not a prepared file. Dot class file is not a prepared file. After moving on to OS here, after moving on to OS here, it prepares as per the current OS. Okay, preparation that linking task is nothing of preparation task. Linking task is preparation task here. So dot class is not a prepared file. After moving on to OS, after moving on to OS here, after moving on to OS here, JVM prepares the dot class file as per the current OS library. As per the current OS library. What is exe file? Already prepared file. Yes, exe file is a already prepared file for specific OS. Exe file is a already prepared file for the specific OS. Okay, exe file is already prepared file. Okay, but Java, what happened? Java dot class file is not a prepared file. At runtime preparation takes place. At runtime preparation, that's the reason it's independent platform. Here JVM takes care of independent platform. Okay, so here JVM is responsible. JVM is the responsible to make the Java is independent platform. Okay, JVM stands for Java Virtual Machine. JVM stands for Java Virtual Machine. Java Virtual Machine. Okay, about JVM we'll discuss. I'll take separate class on JVM. Yes, it's very big topic. JVM topic we'll discuss very clearly. Okay, yes. Now this is independent platform. Yes, how Java is made as independent platform reason is this. Next, one more points. Yes, I would like to mention here one more points. Java program is independent of OS. Java program is independent of OS, but JVM is OS dependent. JVM is OS dependent. JVM is OS dependent. Reason JVM developed in C++. If it is developed in C++, it's exe file, right? And C and C++ exe file concept. JVM is exe file. JVM is exe file. JVM is exe file. This JVM is exe file. So if it is exe file, OS dependent, right? If it is exe file, compulsory OS dependent. That means JVM is OS dependent. Windows is having its own JVM. Linux is having its own JVM. Yes, Unix is having its own JVM. JVM is a OS dependent. For every OS, there is a separate JVM. For every OS, there is separate JVM. Windows own JVM. Yes, for Linux, yes, separate JVM. Yes, for Unix, separate JVM. So different JVMs were developed for different operations. Sunsoft has developed Sunsoft. Okay, Sunsoft they have developed different JVMs for different ways. Okay, see here Windows JVM. Yes, it's exe file. Right? This exe file is already linked with Windows libraries. This JVM is already linked with OS library here. So this Windows JVM is having knowledge of Windows library because Windows library already linked with JVM. Okay, Windows JVM already linked with Windows library. So Windows JVM is having knowledge of Windows library so that it can link it tested.class to Windows library. Okay, see Linux JVM is having knowledge of Linux library so that it can link it tested.class to Linux library. Next, Unix JVM is having knowledge of Unix library so it can link with Unix library. That's it. Okay. JVM is a OS dependent. Now here question is here, JVM, is it part of OS? JVM, is it part of OS? No. JVM is not a part of OS. JVM is not a part of OS. JVM is not a part of OS. Then how can you get JVM? From where we can get from where we can get JVM here? From where we can get JVM here? How can you get JVM here? Okay. Yes. Yes. From where we can get JVM here? Yes, it's a part of JDK. It's a part. Yes. 1 second. Let me mute this on WhatsApp. Okay. Yes. So from where we can get JVM? It's a part of JDK. That means JDK should be installed. Once JDK installed on your OS and getting JVM. JDK Windows, JDK on Windows base, JDK on Linux base, JDK on Unix base. So since JVM is a OS dependent, JDK is OS dependent. Same JDK you can't install on different operations. JDK changes. Let me show the JDK here. JDK. Yes, support downloading JDK 1.8 or 9, something like this. Suppose see. Yes, see development kit downloads Oracle India from the Oracle Corporation. Now it is with Oracle Corporation. Series. Linux, JDK, Java development kit, JDK for Linux OS. Okay, next JDK for Mac OS, JDK for Solaris, JDK for Windows OS. Different JDKs. Now currently Unix nowhere using. Linux using. Okay, in market Linux using, Mac OS using, and Windows OS using here. Solaris is nothing but is Oracle Corporation. Solaris taken over by the Oracle Corporation. Spark machine, working on Spark machine, high speed machine. This is okay. So you can JDK, see different JDKs. They are JDKs. You can download here. From this you can download. Yes, Windows. If it is Windows 64-bit OS. This we should download. Last one we should download. This last one X. Yes, X60 Windows X64 here. 64-bit OS. Yeah, this one last one we have to download. For Windows OS, Windows 10. For Windows 10, last one we have to download it. Suppose if it is Linux based tar file, tar.gz, Linux 64-bit compressive archive. So this one you have to download. Linux tar. Yes, this is RPM. This is for Red Hat Linux base. RPM, Red Hat Pack Manager. So depends on OS that software changes. So region JDK OS dependent. Region. Yes, region. It's exe file. Okay, JVM is exe. So JDK OS dependent. Region it gets JVM. So this is about independent platform. So how Java made us independent platform? Behind of this is JVM. JVM is a OS dependent. See, Java program is independent of platform, but Java is OS dependent. Okay, fine. What's the difference between .exe file, .class file? Let us see. .exe file, .class file. Yes, already some points discussed. Same thing I have prepared here. Yes, same thing I have prepared here. So difference between compile and interpreter. One second. Exe file and .class file. What's the difference between exe file and .class file? Okay, just you try this one here. In Google, just you search for exe file .class file differences. You'll get 1 or 2 points, but you can't get this much of points. This is completely my experience. With my experience, document completely my experience. Okay, my documented contents nowhere matching with any websites on any trainer documents. It's completely my experience. No chance. Okay. Yes. See .exe file .class difference. See exe file. First point. See the first point. What's the first point? Exe file is a binary code file, right? That we discussed already. .class file is a byte code file. Exe file is binary code file. .class file is a byte code file. Okay, right? Second difference. Exe file is system understandable language. Binary code means what? It's a system understandable language. Yes, what is bytecode? Bytecode is a JVM understandable language. Bytecode is a JVM understandable language. Bytecode is developed for the JVM understandable language. Okay, next third difference. Yes, exe file. Yes, exe file. 1 second. Yes, exe file, it contains program codes plus software library and OS library. Okay, what is .class file? Purely Java program. Purely Java program. Don't have any OS library. Okay, .exe file, it contains program code plus software library plus OS library. Yes, .class purely Java program, don't have any OS library. Okay, right? Next, fourth difference. See, exe file is a prepared file for specific OS, right? At the time of creation of exe file itself, OS library linking, statical linking means already prepared file. .class file is not a prepared file. .class file is not a prepared file. Okay, right? Next difference. Yes, OS library. OS library statically linking with exe file. At the time of creation of exe file itself, statical linking. Okay, OS library, dynamical linking with .class file. It's runtime. It happens at runtime check. Okay, so here exe file at the time of creation of exe, but here, yes, here in .class file, OS library, dynamical linking with .class file at runtime. This is at runtime. This is runtime. Runtime, right? Okay. Yes. Next difference. See, exe file is already prepared one for specific OS, right? Okay. So exe file already prepared one before moving to OS. Already prepared file. So already prepared one. Already OS label linked. Already prepared one. So .class file is not a prepared file. .class file is not a prepared. After moving on to OS, JVM prepares as per current OS. Same point already mentioned here. Okay. Yes. Next here. See, exe file executes faster than .class file. Reason here. .class file slowly compared to exe file. Reason here. .class file preparing at runtime. So .class file, yes, JVM takes the bytecode file and linking, right? Linking, time taken for linking, right? So preparing at runtime. See, exe file is already prepared file. Executes faster. But .class file preparing at runtime here, slowly executing. Java program running slowly compared to C language exe file. But Java has many features, many advantages compared to C language. Compared to C language, Java has many features, many advantages. Okay, yes, little bit slower. Okay, to improve the performance of Java application, so many strategies using in the project here. To improve the performance of Java application, so many strategies. Okay, yes, like garbage collection strategy, next JIT compiler strategy, next collection strategy, so many strategies. Okay, yes. Next here, 8 points. See, try to understand this. These are important point. 8 points. To run exe file, application software not required to install. Yes, what does mean here? Suppose here this is Linux base. On Linux base, yes, on this Linux base, here on this already C software installed. Okay, that's the reason I'm able to develop C program. C software installed in the system. In the system here, in this ways, C software installed, C program developed, compiled, and generate one exe file. So dot slash project exe file, right? Dot slash project exe file. Okay, that exe file executed. Dot slash means current working directory. Okay, same project exe file you can run on another Linux base without installing C software. Here C software is available. Okay, to develop the C projects, yes, to develop that project here, C software already installed here. So using C software, we have developed the C program here and compiled, prepared exe file, right? Okay, exe file prepared. Now this project exe file, this can be moved to another Linux similar ways. Okay, another similar ways means Linux base. Similar Linux base. You can take to another Linux base directly can run it here. Yes, again C software not necessary. Again C software not necessary. But when come to Java here, when come to Java here, when come to Java, yes, to run dot class file dot run anyways. Yes, moving on different operations running, right? To run this JVM required. Yes, how can you get JVM? JDK should be installed. So to run the Java program, compulsory you have to install JVM software, Java software. Without Java software, yes, Java programs will not run. Okay, now suppose Java program or Java project development completed after finishing, Java build completed. The Java build moving on to on-site means client location. After moving to client location, at client location also you have to install JDK software, otherwise cannot run. Suppose C program exe file, yes, exe file prepared a Linux base at the development, right? After finishing, maybe moving to client location. At the client location, same ways, like same Linux base installing and running directly. C software not necessary. To run exe files, that application software is not required to install here. To run exe files, application software not required to install. But to run dot class file, we should install JDK software. Otherwise, it won't work here. So this is difference between exe file and yes, dot class file difference. Okay, yes. See, 1 second. Yes, for all of these things, some interview questions prepared. Java installation topic. Tomorrow topic is Java installation. Tomorrow topic is Java installation and Eclipse installation and writing first program. See, this is yes overview of JVM. Next class topic after finishing Java installation and writing first program, Eclipse working after that. Yes, we'll go to JVM. Okay, JVM internals will discuss. See this. Interview questions on every topic prepared. What is OS? Now you can answer some questions here. What is OS? What is an exe file? Now you can answer. Can we create exe file in Java? So what is dot class file? What is dot class file? How Java program file is independent of that? Now we can answer all these questions here. What's the difference between exe file dot class file? What's the difference between JDK, GRE, JVM? This topic next. Yes, after finishing JVM topic, you can answer this one also. Okay, right? Yes, this one also you can answer. Okay, right? Yes, next. So what is JIT compiler? Yes, JVM topic. Okay. Yes, can we compile Java program without? Yes, this topic not yet completed. This topic not yet completed. Yes, we should discuss. Okay. Yes, this topic is tomorrow topic. Can we compile? Yes, Java program without main here. Can we execute Java program without main here? Yes. Yes, what does mean Java is portable? Portable. Tomorrow we should discuss. Tomorrow topic this is. Okay. Yes, can we have multiple classes same Java file? Yes, tomorrow break. Tomorrow topic this is. Okay. Yes. So like this for every topic interview questions prepared. For every topic interview questions prepared. Okay. Yes. Every topic interview questions are next topic. Yes, data types and operators. In that also interview questions prepared. Every topic wise interview questions prepared. More than 500 questions I have prepared in the documents. Just you follow document here. Running notes is not necessary. Yes, tomorrow topic is Java installation. How to install Java, path setting and Eclipse installation. 1 second, Harish is not added up. Okay. Let me check it. I think you have shared your details. I will add it. Yes, sure. Yes, Sheikh Daria Hall. Yes, already added.